These are the notes for Algebra 2, Section 3.5, pages 187 to 190 in your textbook. And they have to deal with basic matrix operations. And before we get started on the basic matrix operations, we want to deal with some vocabulary. Now, we already know that a matrix is a rectangular arrangement of numbers in rows and columns. We saw that when we were learning the matrix method of solving a system. So, the matrix, a rectangular arrangement of numbers in rows and columns. The dimensions of a matrix we also have seen before. The dimensions are the rows by the columns. In other words, we find out how many rows there are, the number of rows. We find out the number of columns, and we get a number by a number. That's our dimension. So, for instance, in the case of the matrix that I have down here at the bottom of the screen, I have 2 rows, I have 3 columns. So this is a 2 by 3 matrix. Those are my dimensions. Now, the numbers in a matrix, each individual number, in this case there are 6 of them, 4, -1, 5, 0, 6, and 3. Each of these numbers is an element of the matrix. Then all the numbers together are considered the elements. And we can specify which element we're talking about. For instance, I have highlighted the element in the first row, 3rd column. This element is 5. But I could just as easily have said the element in the 2nd row, 2nd column, which would be 6. I can specify any of the 6 numbers that I want to by saying what row it is and what column it is. Right, one last definition that we need to get through before we can get started with our basic operations. 2 matrices are considered equal if their dimensions are the same and the elements in the corresponding positions are equal. In other words, if I had a matrix like, 2, 3, 1, and 4, that matrix would be equal to the matrix 2, 3, 1, and 4. Both of these matrices have the same dimensions, and each of the corresponding elements are equal, right? 2, the element in the first row, first column, corresponds with the element in the first row, first column here, which is also 2. 3 corresponds with this 3. It's in the same place in the matrix. 1 corresponds with this 1, same place in the matrix, so on and so forth. So if all of the elements are the same, and they're all in the same order, and the matrices have the same dimensions, the matrices are equal. Now let's look at some operations. There are a couple of different basic operations we can do. One of them is adding and subtracting. All right. If we want to add or subtract 2 matrices, we simply add or subtract the corresponding elements. And we just saw that the corresponding elements are the elements that are in the same place in each of the matrices. You can add or subtract matrices only if they have the same dimensions. That should be pretty logical. After all, we can't add or subtract all of the corresponding elements if they don't all have corresponding elements. So if 2 matrices have different dimensions, they do not all have corresponding elements. If they don't all have corresponding elements, then we can't add or subtract them. Now we have a couple of different examples here. You can see that when I'm adding matrices, I look at A corresponding with E. So I add A plus E, and I get A plus E. You can see that I've got B corresponding with F, so I have B plus F. C corresponds with G, so G plus C. And D corresponding with H gives me D plus H. So my corresponding elements were added together. I can do the same thing when I'm subtracting. Again, I have A and E, but this time it's A minus E. I have B and F, again, and B minus F. C and G, C minus G. And D and H, D minus H. So all of the corresponding elements go together, either added or subtracted. Alright, so let's give this a shot. We want to perform the indicated operation if possible. Now this is example 1 in your notes. So, I look at my corresponding elements. I say, okay, I have two matrices. This matrix is 2 by 2. This matrix is 2 rows, 1 column, so 2 by 1. The dimensions of the first matrix are 2 by 2. And the dimensions of the second matrix, 3 over 2, is 2 by 1. These do not have the same dimensions. They're not the same. So you cannot subtract them. I could only subtract them if they were both 2 by 2 or they were both 2 by 1. But since they're not both the same, I can't subtract them. Alright, let's try this example. Here I have one matrix that is 3 rows, 2 columns, and another matrix that is 3 rows, 2 columns. The dimensions are the same. So I can add these two matrices together. And in order to add these two matrices together, I will add up the corresponding pieces. So I'm going to add -2 and 1. -2 plus 1. I'm going to add 1 and -4. 1 plus -4. I'm going to add 0 and -2. 0 plus -2. 3 and 9. 3 plus 9. 7 and 1. 7 plus 1. And 6 and 5. 6 plus 5. So all of my corresponding elements are being added together. Well, -2 plus 1 is -1. 0 plus -2 is -2. And 7 plus 1 is 8. 1 plus -4 is -3. 3 plus 9 is 12. And 6 plus 5 is 11. So this, I'm going to rewrite this. This is my new matrix. I got this matrix by adding together the elements of the other two. This matrix is equal to these two being added together. Same dimensions and the corresponding elements are the same. Alright, we have a couple more definitions we want to look at. These are back up at the definitions of vocabulary. In matrix algebra, which is what we're dealing with, a real number is often called a scalar. Now, a scalar sits outside of the matrix. All right, numbers inside the matrices are elements. A scalar is not one of the elements. It sits outside the matrix. You can see in our examples, I have elements inside this matrix, and then I have a scalar outside. I have a scalar outside here as well. Those numbers outside are the scalars. Scalar multiplication involves multiplying each element in the matrix by the scalar. So every element in the matrix gets multiplied by whatever the scalar happens to be. So I have 3 multiplied by every number inside this matrix. That means I have 3 times 0. I have 3 times 2. I have 3 times negative 7. I also have 3 times negative 1, 3 times 6, and 3 times 4. Multiply all those guys together. 3 times 0 is 0. 3 times 2 is 6. 3 times negative 7 is negative 21. 3 times negative 1 is negative 3. 3 times 6 is 18. And 3 times 4 is 12. This is the result. This matrix is the result of my scalar multiplication. Alright, this 2 by 2 matrix down here is getting multiplied by the scalar negative 2. So every element of my matrix is getting multiplied by negative 2. So I'll have negative 2 times 1, negative 2 times 0, negative 2 times 3, and negative 2 times 5, negative 5. So negative 2 times 1 is negative 2. Negative 2 times 0 is 0. Negative 2 times 3, negative 6. And negative 2 times negative 5 is positive 10. This matrix is the result of the scalar multiplication on my original matrix. Alright, the last two problems, the checkpoint problems that you have on your sheet, are these two. Pause the video or stop the video, solve the problems. Bring those completed problems with you to class.